Yep. Okay. Thank you, all. Top. So your microphones and cameras are disabled. We'll enable them at the end of the presentation of Simon. If you have questions during the presentation, keep your question for the end of the presentation. But if there's something you don't understand, feel free to ask, and I'll stop Simon if something is unclear. So feel free to use the chat. For the big topics and big questions, we're at the end of the intervention. Simon will confirm, but we might not share his slides. We'll only share the replay because it might go a bit technical. So we want to make sure that you have the explanation of Simon to properly understand the topic. Because once again, I think it will be technical. So Simon, the floor is yours. Go ahead. Thank you for sharing, and yeah, go ahead.
Okay, let's dive into the subject. All right, I think you now all see my screen. And so we are here today to speak about software obsolescence. And basically, just to begin with, I'm already giving you the answer to the topic. Basically, anticipation is the key. So always focus on that during the entire presentation. So in the agenda, we'll talk about different, let's say, global topics. First, we want to just make a quick recap of the different elements that constitute the sustainable IT and where the impacts come from and how does software play a role in that, because we might not always be aware of the full picture. Then, of course, we will dive into the topic, which is what is obsolescence and why does it matter? In the end, we'll see, well, this is kind of a local joke, you know, the Belgian Compromise is how to deal with the different risks and benefits that you can get out of software. And then we'll come to some, I would say, state-of-the-art solution to address this issue of obsolescence. Then, of course, questions will be welcome. My name is Simon Uyttendaele, Simon Uyttendaele in French, and I've been in the past an IT consultant, and I've had lots of experience at different various entities, and I've seen many times the exact same issues, the exact same problems. And therefore, I decided to create a new company, which is called Aeonics, that aims to address those issues that we usually see and view in IT. I'm actually father of 2 daughters, and that takes a lot of time and energy, but I still have time to do some presentation from now and then. I'm more of the technical background, but I try to keep it understandable for everyone. So if you don't understand something that I say, if it's too technical, please let me know. In the end, I'm Belgian, I love beer, and I love cheese. Let's go through a quick disclaimer before we start the presentation. You know, numbers, especially in sustainable IT, when we show numbers, it's like, where does this number come from? It's not exactly that because, you know, the 10 decimal is not exactly the same. Okay, the idea here is not to give precise number, it's to give an order of magnitude to exhibit the trends that we are facing. So I just want to make clear about that. Then, of course, some of the examples that I'm going to explain will be exaggerated. Why? Because we need to acknowledge some of the facts that happen around us, especially around software. So I know that not everything is as dramatic as I could explain it. Of course, the opinions here are my own, and I do not imply anything or anyone into what I'm going to say. So if you agree with me, very good. If you don't, well, let's discuss about it. In the end, throughout the presentation, some of the content will be voluntarily ironic or intended as a joke. So please do not feel offended if ever that happens. All right. Now, let's talk about the implication of software in the overall impacts of the digital sector? Well, you probably know that the impact of the digital sector is often compared to that of the airline industry. And we say in the end, it's better to go to New York back and forth than just to send an email. Well, again, not that order of magnitude, but in the end, it's always good to keep in mind that indeed the digital sector does have clear impacts. Now, what are the components that are involved into those impacts? Well, the first and foremost thing is the need. There is a need for IT solutions. And this need is then driven also by the, well, we call it the usage. And we need to address that. And in order to address this need, we deploy, of course, some hardware that we're going to have the smartphone, for instance, or the desktop, the servers, everything that comes into the IT world. And of course, in order to use this hardware, we need software. So it means that those two guys, hardware and software, are intertwined. You cannot have, it's meaningless to have hardware in the IT world if you don't have the proper software to use it. And the other way around, in order to use software, of course, you need hardware. And it's a very close relationship. And what happens when people use IT to answer to their needs, to a specifically an identified need, is that it creates a bounce effect. And this bounce effect is basically, oh, I have new ideas now. I didn't know that was possible. So basically, the more we use IT, and it's like the snowball effect. The snowball becomes bigger and bigger because we want to use more, and we create additional impacts that we did not foresee. And all this creates basically the carbon emissions. Well, we resume that to carbon emissions, but of course it's water. It is about the minerals and everything that all together the impacts of the IT sector. We'll refer to that in our presentation as the dead fish. Every time there are impacts, it creates dead fish. Now, once again, I really put the emphasis that everything, all the impacts, 100% of the impacts of the digital sector is initiated by a user need. Because if there is no need, no one would do IT in the end, of course. Now, you are probably familiar with the distinction in the impacts between what we call the end user devices, which is the majority, 2/3 of the impacts are created by the enormous amount, the quantity of devices that we have. Televisions, smartphones, laptops, desktop, and all those appliances that we have. Those are massive amounts, and therefore this is the majority of the impacts of the total digital industry. Now, 1/3 of those impacts also is linked to the network and the data centers. Now, you are probably used to that, but let's take a different perspective. We know that, for instance, when an iPhone is actually created, produced, 80% of its overall impacts are created when it's produced, the actual item, the hardware. And 20% is the impact of its usage over the entire lifetime. So it means that we have this ratio between the usage and the actual hardware, end of life, recycling, and so forth. And what we have seen is that actually this proportion is inverted for the hardware, for the network and data center sector. It is actually 80% of the impacts of the network and data centers that is linked to the usage. Why? Because the energy, the air conditioning, and so forth that is required for those data centers to operate 24/7. When we have an iPhone, we keep it probably off during, well, not off, but it's idle in the pocket for most of the day. But the server that runs in a data center, they are up and running 24/7. And so there is a difference of the type of impacts that we have. So it means that globally, just the usage part of IT represents 40% of the total impacts. So it means that if we can reduce the usage that we have today, we can target 40% of the global impacts of the industry. The other way around, and it's caused by, of course, sorry for that, software execution. Because, of course, on your iPhone, on your desktop, on your laptop, software runs. And this software, when it runs, it creates the demand for energy and for air conditioning, for ventilation, and so forth. And so it means that the primary cause of this usage is due to software. If there is no software, there is no need to run anything. What can we do about that? Well, first of all, is use renewable energy. When we have data centers that are powered by coal mines, it's a bit not so good, and it creates a lot of dead fish. And the other level of action that we have is whatever is not actively used, don't keep it running. Many of the machines that we have are still turned on and still consume energy, and they are not used at all. That is the levels of actions that we have to target the usage of our services. Now, the other way around, the hardware part. The hardware altogether, the network and the user appliances, represent 60% of the impacts of the industry. And this is caused by what? Why do you need new hardware? Well, the first, of course, is because it's dead. It doesn't work anymore. It's damaged. Oh, I dropped my phone. It's broken. I cannot repair it, so I buy a new one. That's the cause number one, of course. But then we see that the software actually has requirements. You need to have at least this capability on your phone, on your laptop, on your server. And if you don't have that, you cannot run the software. And therefore, it means that the software imposes to buy and to create and to use new hardware. Then, of course, there are some other factors. I'm not going to list all of them over here, which is, for instance, fanciness. I want the iPhone 9 because it's just cool. And don't forget about it, tax optimization. In a company, legally speaking, after a few years, a laptop is, from the accounting point of view, worth nothing. And so you have an incentive as a company to renew the hardware in order to have, a tax optimization. And that's a reality today. So what can you do about that? Well, you've seen it, you know it. Sustainable IT is about it. Expand the lifetime of the device. Try to use your smartphone longer. Try to use the server in the data center longer. Reuse and recycle whatever you can. Overall, what do we see? The level of actions and the causes that we have. When we look about it, basically what we do about it, use renewable energy, expand the lifetime, and so forth. We are trying to act to counter the consequences of IT. But we don't address the actual cause. The cause of usage is the end of life, of course, but also software. So it means that the software causes new hardware and also all those impacts. So basically, what we can see is that overall, almost 60% again of the impacts of the IT industry is linked or caused by the software. Now, how can we address that? How can we make it such that we act at the software level in order to reduce the need for energy, for usage, and also for new hardware? How can we do that? Well, the key is try to do things in an eco-responsible way. And please look at sobriety. Sobriety doesn't mean that you have to go back to the 3rd century or something like that. No, it just means please care for what you do. What do we have available today? Today, we have tools and specialized companies that are able to measure the impacts of the services that we have today. And the goal is to improve that. So for instance, when you have a website, we can fairly easily measure the impacts that this website is going to create, because we can analyze, for instance, the size of the network transfers, of the image, of the execution of the code that is going to run on your laptop. And that is fairly easy because we can observe it, we can see it. But this image, it comes from basically the cloud. What? Cloud remote service. And at this level, we basically have no clue what's in there. No one can measure, because no single cloud provider is even able to. It's not that they don't want to, they are not able to provide accurate numbers. But there is a fact that we know, is that in the cloud, there are plenty of servers and plenty of databases and basically plenty of dead fish. So whenever we can measure the actual impacts of an application that we can see, we have no clue about the dead fish that it creates. That's just to focus on the impact and the importance of the software. Now, what defines obsolescence and why does it matter? I've asked my best buddy, which is ChatGPT. You probably know it because of the trend. And it told me that the obsolescence matters because it can have significant economic, environmental, and social consequences. Okay, that's great. It does matter. But to what extent and what can we do about it? Basically, it creates dead fish. Now you have to know that 100% of obsolescence is due to a simple rule: change over time. If there is no change over time, if everything stays still and steady, there is no obsolescence. It just works. Whenever there is a change that is happening after a while, it can create obsolescence. Let's look at it from a graph perspective. When we have the actual need that we want to answer, and we have software that is dedicated, that is working perfectly, and is compatible with the hardware, everything runs fine. But at some point in time, for some reason, every good reason in the world, it could be because there are new standards, there are new security measures, or the technology has changed, we need to create a new version of the software. And from that point in time, it might create actually incompatibilities. Because the software now, we removed a functionality, and so it doesn't answer the full need anymore. So the users are not able to use the application because it does not answer what they're trying to do. Or it could be that the application is no longer compatible with the existing hardware. So we need to buy a new machine. But it could be the other way around too, is that basically the users, they are not used to using that software and they don't know how it works and so on, so they don't use it, and basically it makes it obsolete by default. Or it could be that the older hardware is also obsolete and does not support the new software. So how can that be? And what do we do then? Well, there can also be a change in usage. Because I have a need as of today, but maybe in a few years I will have another need. And it means that the application that is existing does not answer my new need. So that creates obsolescence because I don't use that application anymore. It is not a fit. And the same goes for hardware. There is a new version of hardware, and unfortunately, my software is not compatible because there are new requirements. It's a complex story, and we all know how it goes. And the only time at which things can work again is when everything is aligned. And so it means that the slightest change in need or usage in software or in hardware might lead to obsolescence. And what are the consequences? We need to realign everything for it to work. Realign how? By changing the audience type. Oh, you have to learn now to do electronic payments. Yes, but I'm used to do cash payments only. Ah, well, you know, that's the new trend. If you cannot deal with that, just stay in your cave and don't buy anything anymore. Well, is that acceptable? Oh, I cannot use that software because it's not compatible. Okay, you need to buy new hardware. It creates consequences. Consequences, again, at 3 levels, thanks to my ChatGPT friend: economic, dead fish, and social. You're going to exclude, involuntarily, I suppose, people from using your technology because simply they cannot cope with the change. And basically, you leave out a part of your audience because they are not able to follow the trend. And those are consequences that in the sustainable IT world, we tried to avoid. That is linked to obsolescence. Now, why does that happen? Let's take a typical scenario. We have 3 actors, which are cliches. We have the boss, we have the geek, and we have the end customer. The end customer is the king, because if it doesn't fit the need, they will not use it. What are the characteristics? What are the focus points of those actors? They are not aligned. They are not the same. The boss, for instance, his only concern: I want the minimum expenses, maximum revenue, and of course, it should be available right away. Basically, he's a bit narrow-minded. He doesn't see the big picture. He just sees his direct return over investment. I want more shareholders. I want everyone to be happy, and I want to make money. And I don't want to spend money. I want to make money. Cliché. The geek Well, the geek, he wants to avoid the responsibilities. Oh, you know, I'm not the boss. You just ask me, you tell me what to do, I will do it. And I try to have fun when I do it because I like new technologies, you know, I like to play with stuff and I set up some stuff, but I don't actually want to work. So I do the least amount possible. And so there, I can just play my favorite game online. And again, it means that the geek is too focused on the technicality, the technical details. And it's a waste of time, waste of resources, and in the end, fanciness. Because we love this new chat GPT, it can write code for us. Wow, we don't even have to do anything anymore. Can you believe it? But in the end, that leads to misunderstandings and misaligned expectations. In the end, the end customer, they have no clue about what is the technology behind the application that they are using. They don't know if it's actually true or false what we tell them. But there's one thing, they don't like change. If you change the position of a button in your application, they will just uninstall it because it was always better when it was before and I don't like the change. But in the other way around, I also expect whatever application, because you know it's IT, it's fancy, there is artificial intelligence, so just make it work. And I want my app on my iPhone to actually bring me a cup of coffee. But that's not how it works. And so in the end user is always kind of frustrated about the software. It doesn't exactly do what they expect. But in the other way around, they are not so quite able to express what is it that you want. Yes, but I want a button that is basically activating, and they are getting confused in the thing. So it's very hard to put everything together. So what happens in the life cycle of an application is that the boss is asking for something that cannot be done, that the geek does not know how to do it, and that leads to something that doesn't work at all. Well, we try to make it work however we can, because technically it's hard, it's complex. And basically the geek, one of his characteristics is like he doesn't like responsibilities. So he uses the famous umbrella technique. It's not my fault. And the result is a setup that is using technology, that is basically using dead fish again, creating dead fish, and that delivers something to the end user. Now, have you ever been to an administration? I very like those administration, but a typical ironic scenario is that you go to the administration, you ask for a document, and then the person behind the desk tells you, oh, you know, I'm sorry, but the software doesn't allow me to do it. How is that possible? How is that possible that actually a tool, software, IT, is a tool that is supposed to bring the user ease and to speed up their things and to make life easier, to answer their need. And in the end, it creates the total opposite. I cannot do that because the software blocks me, which means it's already obsolete, whereas it didn't even start yet. The slightest change in technology, in data type and so forth, will be a catastrophe because the solution that we have provided is not resilient. We did not anticipate the different risks compared to the benefits that it gives. How about it? How about the risk and benefits? What is this Belgian compromise that everyone is talking about? Well, even ChatGPT is able to tell me. The Belgian compromise is basically a framework for cooperation and compromise. The idea is that we shouldn't be just one isolated from the other and then say, okay, we'll do this, and it fails. No, let's speak to each other again. And it means that we need to include everyone in the loop. It should always start from the need. Does the application that I want to do, using the hardware that it requires, does it answer an actual need? If it does, let's ask the boss and the geek, what is it that it's going to require to make it run? How can we make it efficient? How can we make it eco-designed, sustainable, sober? And how can that bring an economic value? Because, hey, I want to eat at the end of the day. So the application that I create, of course, it must create economic value because people depend on it to live. How can that be all together? And remember one thing, if you want to foresee the obsolescence, you need to keep it simple. That is the KISS principle. Always keep it simple. If you go too complex, it will fail. So the key, once again, is anticipation. You know from the graph that I showed earlier that 100% of the cause of obsolescence is linked to a change over time. So we just need to anticipate. But what is actually going to change? Good question. We don't know. And when is it going to change? Well, by definition, you don't know either. Okay, so you're trying to tell me that I should anticipate something that I don't know, that is going to happen sometime, which I don't know. That's exactly it. You have to accept the fact that some of the things are unknown. And instead of trying to go for the super solid thing, just deal with flexibility. The service, the digital service that you should build should account for this and should know that there is some flexibility to have when there's going to be a new hardware, a new iPhone that is going to come out. Is my application going to be able to use it and to run it, or am I going to require to just redesign and redevelop everything? Whenever that's going to happen, I don't know. It might be tomorrow. It might be in 5 years. When there's going to be a new technology, quantum computing, is that going to have an impact on your services? Do you know? I don't know. How can we make sure, or at least try to make sure, that the impact that it's going to have are going to be minimal? One of the simplest but most effective idea is to split a digital service into at least 3 components that should basically have their own life cycle. The presentation is like the visualization. It's a website. It could be a smartphone application. It could be a hologram that doesn't exist yet, but that will in the future anticipate the change. We don't know, but that is the presentation, how the user is going to interact with the application. Then, of course, there is the logic itself. The data handling, where do we go stuff. This usually runs in the cloud or on servers. And this logic is the same. 1 + 1 = 2. It doesn't matter if it's an iPhone. It doesn't matter if it's a website, because 1 + 1 = 2. And in the end of the line, of course, you need some data. Data need to be stored. And for instance, you had traditionally SQL databases, And now there is a new trend that just came out, which is NoSQL databases, and that introduce a completely different paradigm of exploiting this data. But it doesn't matter for the end user. The end user has the same app on the same iPhone. And so it means that changes in each of those components should not affect the others. And that has a name. That is called separation of concern. The presentation is not the same concern as the logic and is not the same as the data structure and the way it is stored. Let's take an example. We have, for instance, a service that has two different front ends, two different applications. One mobile app for the end users and one website, for the admin so that they can manage and stuff and so forth. And it's going to use three simple services, which is I want to fetch some information so that I can display it. Of course, it's two ways. So I want to save information as well. And I want to click on a button, it's going to run an analysis and so forth. And behind the scenes, I may have two different data sources because one is too easy. So let's just pretend we have two different sources of data. In order to handle that at best, the idea is state of the art to go to a service architecture. And we call it microservice architecture because we split the functionalities into different independent blocks. So the middle part here with the servers, it means that fetching the data is completely independent from running the analysis because it doesn't target the same goal, the same need. And one application might use one, another application might use others, and we don't know. But we make functionality available as independent block. And that allows them to evolve and to react to change over time. That is the principle. Now, how do you do that? Well, state-of-the-art architecture for microservices is basically to encapsulate a functionality into sort of a virtual machine that is called a Docker. Those virtual machines have to run on some physical machine. But there might be multiple physical machines and multiple services which need to be orchestrated by some kind of component. And of course, they need to access some storage and to have logging, of course, because if something goes wrong, you want to know about it. And those Dockers in between each of them, they are going to communicate over some asynchronous service bus with publish, subscribe, and queuing with acknowledgement. And of course, we want to make that resilient, so it's going to run in different availability zones. And basically, it's going to create lots of dead fish again. Basically, what we see that we have set up in our system is, first of all, overly complex and hard to maintain, but also that we are, of course, using the cloud and some provider to host and to make it run. And even if the system that we have designed is small, yet scope 1, scope 2, and scope 3. Scope 3 is the most important. It means that the cloud provider that you have to use, even if you just use one machine, the cloud provider, in order to answer to your need for this infrastructure, they have to deploy hundreds of servers. And hundreds of them are just going to be idle and not doing anything. Just to provide the fact that when you say, next, 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 I want to order a new machine, I want to have a new service available in the cloud. Next, 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 and within the 5 minutes, you have it, which means that the physical machines are powered on and are installed in the data centers. They are running 24/7 doing nothing. And this is your scope 3. So what we want to have is to have this principle of this resilient infrastructure that creates actually living fish instead of dead fish. And this is what we do. This is what I've been trying to do in R&D for more than 8 years now, is have this microservices orchestrator that is basically a single unit, very easy to deploy, and that's going to handle this compatibility and this future-proof solution for the software that you are going to create and distribute between your front-end application that is dedicated to the user, exploiting whatever data that may change in the future. Of course, it's always the Belgian Compromise, because it's a new tech. Who wants to use a new tech? Well, in a way, it's a compromise. So what can you do about it? You, yourself, you. Basically, if you don't have the knowledge, you cannot do pretty much. You just have to ask questions. And raising those questions will actually give you a nice hint about what is going on. And those questions are these. Well, please tell me, Mr. Boss, Mr. Geek, what is the impact of change over time in one of the application components? If there is a new iPhone, what happens? What is the impact? Do I have to rewrite everything? Am I still compatible or not? Second question, what is the overhead of the system itself? It means that, for instance, if you have an algorithm that computes 1 + 1 = 2, and that, let's say, it takes 1 second to execute 1 + 1 = 2. That's the business logic. You cannot reduce that amount of time. It's required. But then the system itself is going to have some overhead because it goes through the network, through the cloud, to different machines, to the database. How much time is necessary on top of the actual useful time for the service to run? Because if you trigger the question to your system, please compute what 1 + 1 = 2, and it takes actually 3 seconds to execute, it means that for every useful task, every useful second, there are 2 seconds of wasted overhead. You cannot avoid the entire overhead, but you can try to minimize it. And that will give you a good idea about the efficiency of your system. Third is, okay, how does the system behave when it's idle? When no one is using the system, does the system still use resources? How much? And how does it compare when the system is actually busy or overloaded? There are too many things going on. What is the difference in consumption, in resources that I have to deploy between being idle or being busy? That will give you a good idea on the resilience and the scalability of your system. Fourth question, very important. What are the skills required to maintain the system? Because in the end, if you use old and outdated technology, no one on the market has the knowledge to maintain that system. And that is a form of obsolescence. The other way around, if you use super high tech, it's great, but in the end, it means that you need super high qualified people, which are basically not on the market, not available. You don't have the people that actually have the knowledge to maintain that system. and that's obsolescence. And last but not least, what are the dependencies of the system? Dependencies at the hardware level. What is your minimum requirement? At the operating system, do you use Windows? Do you use Mac? Do you use Linux? And which version of which? And if there is an update in Windows 11 that goes to Windows 12, is that going to create an incompatibility or not? I'm using an external tool library that has been written by this guy on the internet. Okay, what if this component of my application disappears for whatever reason? What is the impact on my system? Asking those 5 questions will give you a nice overview about the resilience of your application to change over time. And change over time is what causes obsolescence. That's it for the presentation. Now, Jules, I think you can open probably the chat. If anyone has questions, I will be very glad to answer them.
Okay, nice. Thank you for the view. I mean, your point of view. Thanks.
Sure.
It was really interesting, and indeed, there's a lot going on in the background that we don't see. So, oh, should I? Okay, so authorize microphone for anyone, yes, and authorize cameras for everyone, yes. So actually, if someone wants to ask a question or activate his camera, you're now free to do it. So any question, now is the time.
If there is no specific question, I want just to add a little sharing of experience, because that's also the topic as of today. Is what we've done at one of our customers. Well, actually, it's not a customer because we didn't end up doing business with them. We did implement a sober architecture compared to the existing solution. And they were working in the industry. And in the industry, you have old machines in factories, and a factory is not built in one single day. So there are new factories with modern appliance and the old factories, and they have to communicate all together to get metrics to analyze what's going on. And by implementing a sober solution in less than 1 week, 1 week we're talking about, we managed to divide the cost of the infrastructure, the cloud services that they pay every month. We could divide that by 800. Not divided by 2, not divided by 10, divided by 800. That is the kind of thing that is actually achievable using sober, nicely designed architectures. And I will never put enough emphasis on, please do the right choices, and the most obvious solution may or may not be the best for the use case that you are trying to solve. So I see a question from Mathieu about my sources. The sources from the numbers that I showed basically in the first part of the presentation are given by the different research which are done first by ISIT and the INR, so the French part of ISIT, and which then, of course, those numbers are based on the research from the Shift project and other independent. In France, they are pretty advanced in those analyses, and the ADEME publications also give a hint about those numbers. Now, of course, there are some assumptions that were drawn with regard to the implication of the obsolescence on the hardware level, because there is no official study yet that proves, and to what extent, that obsolescence of the software causes, and to what extent, the need to buy new hardware. We know it happens but we cannot really quantify it. So those were just, you know, best guess estimation, with, of course, different sources of, you know, studies that have been drawn. So I have another question over here, which is, did we ever consider second-hand licenses for hybrid cloud? The thing is, yes, we have considered it, and actually it works. So for example, in one of the, well, in some cloud providers, maybe all of them, I don't know, but at least with one of the cloud providers, which starts with an A, and I won't say the rest, basically they have this, what they call degraded kind of infrastructure, which is basically we give you access to machines which basically are no longer used by active paying customers. So instead of decommissioning those machines, we give you access to those machines in a degraded way, kind of. And it means that those providers don't have to renew the hardware so often. So there are alternatives. But again, whether or not the hardware is reused, it still uses energy, because again, consider that at the network and data center level, 80% of the impacts are caused by the actual usage. Not actually, well, of course, the hardware has an impact. The more you add hardware, the more you add impact, of course. But using that is anyway creating impacts. And whether it's, you know, decommissioned machines that you still reuse or whatever, the less power and the less machine you use, the better. All right, Jules just added some references in the chat if ever you want.
Yeah, some of them. We can add more, but
yeah. Eventually, yeah, we could post more, but you know, the references are well, in the IT, in the ISIT, of course, I'm because I'm biased, because I'm used to those numbers and I know the sources by heart. I didn't like keep a list of full references, but there are many of them which are just the main big trends of resources. Of course, be careful that the impacts of the cloud, and so the usage part, is heavily linked on the energy mix of the location that you are targeting. So as a cliche again, if you go to Germany, it will rely on coal, which is not very nice, create lots of dead fish. But if you go to France, cliche again, it's going to be very good because it's all going to come from nuclear, which doesn't create as much CO2. So it just means that there are differences, and that will also impact the percentage and the ratio that you have. But again, the first source of consumption is basically what you use. If you don't have the need to use more machines, the better.
yeah, I also took the liberty to add so the directory of the Green Web Foundation. So you have a map with all providers in Europe and I think in the world. And if we have information, we have the PEU, power usage effectiveness, and on top of that, indeed, you can find, and I can give the link on the website of ADEME. You can have basically the gram of CO2 equivalent per kilowatt-hour produced in each country in the world and in Europe as well. So I will share this. But I think maybe Adeline, you have a question? Because I see that no. Okay, my bad.
There is another remark from Mathieu in the chat asking if I did read Philippot's Impératif de la sobriété numérique. Actually, I don't recall that particular title, so I would be glad to look it up. Now, I think that pretty much we all agree that sobriety is it's a requirement at this stage. It's no longer something that is just a nice to have. And the goal of this presentation was to emphasize on the role that we have at the software level, because what we are used to here is that, of course, we should take care about the hardware that we use, the smartphone and so on, which is very important, but we tend to let the software part a bit aside just because we don't know what's going on. We don't know in the cloud. We try to guess the numbers, but it's very hard. And anyway, in the end, it depends on the geek that is going to implement the solution. And today, there are not so many alternatives. All right. I don't see any other questions at this stage. If ever you're interested, or if you want to know more, if you want to discuss it with me, I'm happy to discuss it and be challenged. Please be critical about what I said. Please be critical when you read something. Ask yourself, is that possible? Is that true? And then, of course, I'm open for discussion anytime. You know where to find me. I'm on LinkedIn. You can contact me by email. I didn't write actually my email. Maybe Jules, is it in the directory of the ISIT? I don't know.
On the membership space, yeah, but I'll share it in the chat if that's okay with you.
Contact me, yes. And if you're interested also to see, well, a bit of ads here, again, disclaimer, if you're interested to see, well, what is it that we did at Aeonics? How does it work, and how could we achieve more sobriety when deploying those type of microservices architecture? I will be very happy to share that and probably do a demo with you and see what we can achieve together.
Okay, so I think we're good. Unless someone just ask a question in the next minute, I think we'll close this. So the replay will be made available. Yeah, and I think the key message is try to do less. Less is more, right, Simon?
Yes, exactly.
So let's, yeah, okay. But yeah, there's a lot to do, and indeed, it's more like a global way of thinking and organization. So thank you. I think there's no more questions. Linda, I see that you're writing something in the chat. So nope. Yeah, many thanks. Okay, well, thank you, Simon.
Thank you, Jules, and thank you for ISIT for this opportunity to share a point of view. And I hope it's gonna, be distilled in everyone's mind for the next days or hours at least, because indeed, everyone I think needs to really acknowledge the fact that there are some things that can be done, and it's not a fatality that we create impacts. Of course, it will. Every activity does. But maybe we can reduce this impact, and especially unnecessary ones.
Yeah, that's the idea. Okay. Thank you, Simon, again. Thank you for everyone who was here, and have a good one. Have a good day.
Bye-bye.
Bye. Thank you, Simon.
Thank you very much. Bye.
I see that